We're asked to find the solutions of the equation tangent squared x is equal to 1. We would recognize this as if we took and tried to solve something like the y squared is equal to 1. When we took the square root of both sides, we would have that y would be either equal to plus or minus the square root of 1 or plus or minus 1. This could be the same case in tangent, where we're actually looking for tangent of x is either a positive 1 or tangent of x is equal to a negative 1. We could also see this by bringing that 1 over to the other side and then factoring. Tangent squared x minus 1 is the tangent of x minus 1 times the tangent of x plus 1 equaling 0. Therefore, either the tangent of x minus 1 is 0, giving us the tangent of x is equal to 1, or the tangent of x plus 1 is equal to 0, resulting in our second equation. Therefore, we can find our general solutions. We would know that the tangent of x has a period of pi. Therefore, if we found the quadrant 1 angle, adding that period of pi, we'd have the quadrant 3 angle. Therefore, the tangent of x is equal to 1, where sine and cosine are the same. That is equal to x over pi over 4 plus the period of tangent. Likewise, tangent of x is equal to negative 1. If we find the quadrant 2 angle, adding pi units would give us the quadrant 4 angle. Therefore, we're looking for our quadrant 2 angle with a reference of pi over 4, giving us x is equal to 3 pi over 4 plus n pi. If we started listing the solutions off of our first equation and our second equation, we could think about how we might combine them into a single general solution. So for when n is 0, I get pi over 4 and 3 pi over 4. When n is equal to 1, I get 5 pi over 4. And over here, when n is equal to 1, I get 7 pi over 4. If I think about what is happening between consecutive solutions, going from pi over 4 to 3 pi over 4, I really added pi over 2 units, or half that period. Getting from 3 pi over 4 to 5 pi over 4, again I added 2 pi over 4 units, or pi over 2. Therefore, my solutions occur every pi over 2 units starting at pi over 4. Therefore, I could write one general solution as x is equal to pi over 4 plus n pi over 2. In the next problem, we're asked to find the solutions of the equation cosine y minus 1 times sine y minus 1 is equal to 0. We could use our zero product principle, as this would state that either the cosine of y minus 1 was 0, or cosine of y would equal to 1. We'd also have sine of y plus 1 equal to 0, or looking for values where the sine of y is equal to a negative 1. We would find the general solutions for each of these cases. For cosine of y to be equal to 1, this would occur at 0, 2 pi, 4 pi, 6 pi, every even multiple of pi. In other words, we could write y is equal to 2 pi n, or 2n pi. In our next case, we're looking for values where sine of y is equal to negative 1. Sine of y is equal to negative 1 at 3 pi over 2, and then we would add on the period of pi, or 2n pi.